In this video, we're going to take a look at how to solve a compound inequality such as the one you see here by graphing using a graphing utility and also with tables. And we'll do the tables within that graphing utility also. The graphing utility we're going to use is Desmos, which you can either download as an app free or you can go to desmos.com to use. Now notice I have things color-coded. The -3 is in red, and that is your left side of your equation. The compound inequality has three parts, a left side, a middle, and a right side. Each of those has to be graphed separately. This -3 is in red because when we go to Desmos, I'm going to have that graphed in red. And since it's going to be y equals -3 when we graph it, it'll end up being a horizontal line. Because when y equals a number, that's always a horizontal line. In the middle, you see 3x plus 6, and 3x plus 6 is in blue, so when we go to Desmos, you'll find that we have this middle section as 3x plus 6 in blue on the graph. And then the right-hand side is in green, and that's 9, so we're going to have a third graph on our picture, and that's going to be y equals 9. Now we're going to be looking for where this blue part here is going to be greater than or above the red part. We're also going to want this blue part here to be less than or equal to the green part or below the green part. So let's look at our graph and see what this looks like. And when we're done with graphing, we'll go to the tables. So on our graph, notice that I have y equals -3 here. And down here you see a red horizontal line at the level of y equals -3. We also have a blue line, which notice I used f of x. I did that so that we can do the table later. It just replaces y and works the same. So we have f of x equals 3x plus 6 in blue, and that's this slanted line here that has a positive slope as you go from left to right. So that's going to be that part there. And then the green is the y equals 9, which is this horizontal line here. Now, and that's at the level of 9. These spots where they intersect, down here the red one intersects the blue one at this ordered pair, -3, -3. If you graph these three things and then just click into the blue area, you'll see these gray dots, and you can just click on them and it tells you what that location is. So right there is where they're equal. Notice that after that point, as you go from left to right, so the things that are larger are above the red line for the blue. So the blue is above the red from this spot at -3 forward. But we need the blue to stay below the green one also. And notice when we get to x equals 1 right here, that's when the blue equals the green. And after that, it's above it. We want the blue to stay below it. So we want everything from x equals 1 over here to where x equals -3. Let's look what that looks like for our solution set. So we have this graph here, and what we're doing is we're trying to solve -3 less than 3x plus 6 less than or equal to 9, and we're trying to do it just with this picture, not by algebra. So right here at -3, that is where the blue equals the red. We want to get as close to that as possible without touching it. And we want to know where the blue is above it. Well, the blue is above it in front of that, which is this direction. So I'm going to put a round bracket here. Interval notation is a round bracket since we don't actually touch that. We just get as close as possible. It would be an open dot if it was set builder notation. Notice that right here at x equals 1, that is where it equals the green line there. Anything before that x equals 1, the blue line is below it, and we want the blue line to stay below the 9 level. So we want everything before that, which in interval notation would be a square bracket there. And notice that everything we're looking for is right in between that. Everything after the 1 is above the level of 9. So we For this inequality, we're not wanting that. In interval notation, we would want everything from this -3 if we're going left to right. So we'd use a round bracket, -3, then a comma, and then we go up to the last thing that we get to, which is this 1. And that 1 is included, so we'd use a square bracket. So this is what your interval notation would look like for this particular problem. But what if you're asked for set builder notation? Well, set builder, you need to start with a set bracket, and then since our letter in this problem is an X, we'll do an X. Then we use a straight line, which is shorthand for such that. And then our X needs to be greater than -3, because that's this location right here where the blue started to be above the red. And then it has to stay less than or equal to 1, because that's where it ended up equaling the 9 level or the green line, and anything after that is where we started to be above it. So this would be your set builder notation. Now what if we changed this slightly? What if these inequalities had not been what they are? I'm going to change them in red. What if this one had been like that? And this one had been like that instead? That would change our solution. So in red, I'm going to do what those inequalities would be. Now we want this -3 to be greater than the 3x plus 6. That means the red has to be above that. Isn't the red above your blue from here backwards? Well, we're not going to include the spot where they meet, but we want to get all the way up to that spot where they are equal, which is at -3. And we want everything before that, because for the red inequality that I just changed, the horizontal line at -3 is above the blue for -infinity up until -3. So in our new inequality with the symbols the opposite way, our -3 is greater than the 3x plus 6 from -infinity to -3. Now I'm doing this because there's something interesting that happens with your interval notation. We also want to know where this 3x plus 6 is greater than or equal to the 9. That's where the blue is above the 9. Well, that happens here. Your blue is above this 9 level here from this point at 1 forward. Notice there's a gap between these two sections when our inequality has these reversed symbols. Since there's a gap, we want both things to happen, one or the other. You can either be in the area back here and satisfy the new inequality that I changed, or you can be over here. So if your symbols are the opposite direction, you use a union symbol since there's a gap in the middle, and then we start up again with a square bracket at 1, and we continue to positive infinity. So if you end up having the solutions satisfy the inequality on the outsides, you're going to probably end up with a union symbol in between them. If it satisfies things the way our green one did in the middle here, then you won't need it, and it'll just look like this one did. The only thing that happens on your set builder for our new inequality is your symbols flip over. There's nothing really different about writing your solution in set builder notation, but interval notation, since there's a gap in the middle, you need that union symbol. Now, let's take a look at the table for this one. We're going to go ahead and go back to Desmos, and I'm going to create a table. Notice that I used an f of x on that blue. That makes it so that I can actually go and insert a table, and I can define a bunch of values. So let me start my table at -5, and maybe I want everything to go up by 1. So I'll do -4, and then Desmos knows that everything's going to go up by 1, so I can just hit enter and get a bunch of other values. I'm going to go from -5 to 5. Over here, since I had named my blue thing f of x right here, I can highlight this now, and change it to f of x1. Notice my table automatically fills in. If you're trying to solve this with a table, what you want to do is you want to look for where the values are the same. So let's go ahead and take a look at just this table. If we look at just this table, notice that our values are -3 right here. So my y value here is -3, and our inequality was -3. We'll use the original inequality we had been doing. -3 less than 3x plus 6 less than or equal to 9. So we have a y value of -3 right here. Look for your y values. I need the -3, but I also need to find the 9. In my y values, there's a 9 right here. So look at the 9 right there. That's where the inequality equals the -3 and where it equals the 9. What we need to do is examine the table before that point where it's -3, so up here, after it, and then also after the 9 and see what happens. Since we want the values right here to be greater than -3, you want to go ahead and take a look at these values before and see, are those bigger than -3? And they're not, they're actually smaller. Notice in the middle, we have 0, 3, and 6. Those are all bigger than -3. So those satisfy this thing here being greater than -3. Now look at the 9 here. We want the values for our f of x to be less than or equal to the 9. We equal the 9 right here. If you go this direction, notice these y values here get larger. They go above 9. We don't want to be above 9. We want to be smaller than 9. So it looks like everything in this area has y values that are between -3 and 9. So that's where our solutions are. Now, some people will confuse these y values for the answer. They're not. They tell you where the answer is going to be. You find out where the inequality is going to be true using the y values, but your answer is actually the x, because notice we have an x value in our inequality. We're actually searching for the x values that make this true under the y values. So that happens in between. Notice that this inequality needs a round bracket if we're doing interval notation, so it would be a round bracket here. Then we'd continue on until we got to the 9 on the y, which is going to use a square bracket because of that inequality. So we'd go down to here and use a square bracket. This is from -3, which has a round bracket, all the way up to the 1, which has a square bracket. So our solution is from -3 to 1. And -3 has a round bracket, and 1 has a square bracket. If we're doing set builder notation, it'd be exactly the same as what we did with our graph, where it'd be the set of all x such that x is greater than -3 and less than or equal to 1. So with your tables, look for where the inequality is satisfied in your y's and use these x coordinates over here for your solution.